Hello friends, thank you for watching this video. I am Mohamad and today I will be explaining to you what is Grpc, what's the difference between Grpc and Rust, and how we can use it in our application. So, what is our agenda for today? First, we're going to be discussing what is Grpc. Then we're going to be doing some comparison between Jrpc and Rust. And then we're going to be discussing the structure of the application that we're going to be building. What are the tools that we're gonna need to get started, and then we're gonna be jumping into the code. If you find this video helpful, please like, share and subscribe. It will really help the channel. So, what is Grpc? Grpc is a modern high performance way to communicate between applications. It's a popular open source remote procedure call framework. The Rpc framework makes it easy for apps to talk to each other. So, Jrpc is basically built on two things. First, it utilizes HTTP2, which is its transfer protocol layer, and it also utilizes Protobuf, which is the serialization technology and the language neutral contract language. So basically what that means that everything that we need to send from the application to the client or from client to the application, it will be serialized utilizing the Protobuf technology, and it will be sent. So Jrpc is designed for modern apps, specifically microservices. It's some of the main benefits. It's high performance, it's platform independent, which means that it doesn't really matter with which client are we communicating, as long as they have the necessary files installed, they will be able to utilize them. And Jrpc is implemented almost with any modern programming language. So that means we can find Jrpc with .NET, with Java, with Python, with Rust, with Go. So no matter what the client and what technology the client is built on, we can utilize Jrpc. What's the difference between Jrpc and Rust? So let's look at the first thing, which is content. So Jrpc is basically contract first. It utilizes something called a Proto File, which we're gonna delve more into when it comes to building our application. But basically, it's an opinionated contract first Rpc framework. So what does that mean? So basically, for the client and the server to be able to communicate with each other, they should both have something called a Proto File. And this Proto File, it needs to be exactly the same on both client and service. And this Proto File is what's used for the application to auto-generate its code, and what we invoke in order for us to send a request and to receive a request. But when it comes to Rust is different. Rust is content first. So what does that mean? So Rust basically, no matter what you do, you can just send the request, and the API, if you follow the same REST protocol, you will be able to send it. And as long as the API is able to understand your request, it's going to be able to process it. So as long as you know the correct URL, the body format, you can just send any request without having any prior knowledge to how the REST API work. But in Grpc, you must have that Proto File installed within your application in order for you to communicate between the client and the service. So as well, the Jrpc here, the Proto File is strongly typed. As well, when it comes to Jrpc, the contract is defined in Proto File, as we have discussed before, which is really the heart of the Jrpc. It's defined the APIs and the messages that we are going to send. It's language neutral way to define APIs, because the file we passed it is to other languages, use it in the same way to generate the different services. So let's say we have a client which is built on Go, and we have a service which is built on .NET. So as long as these two applications, or the client and the service, use the same Proto Files, the automatically code generated based on that Proto File will be the same no matter what platform they are using, and they will be able to communicate. The second point is basically we're gonna be talking about is HTTP. So within Jrpc, content is binary, and it utilizes HTTP2 and Protobuf, which is our binary protocol. And basically, the Jrpc is designed in a way that it's built for computers and high performance. So the body that's being sent between the client and the service is binary, and it's not human readable, but it's way much more efficient than the text that we send between a client and a server in the REST API. So when we're sending, for example, so REST API utilize HTTP 1.1 and JSON, which is text-based and it's human readable. So the difference is when we send a request from a Jrpc to a Jrpc client to a Jrpc service, we're sending it directly in binary. So this will make it very much, it will make it easier and way faster in order for us to process that request. But in REST API, when we send it from a client to the service, basically we're gonna send it, we're gonna serialize it, we're then gonna deserialize it, we're gonna convert it to binary, and then once the process is requested, we're gonna serialize it again, and then once that's done, we're gonna send it back, convert it to text, and then send it back to the client, which is gonna do the same process, which is gonna be deserializing it, convert it to binary, read it, and process the data. So you can see here the difference between the Jrpc and the REST. Jrpc is high performant, it's very fast, it utilizes binary in order to send the content between the client and the service. So the main difference is between the two is, so Jrpc is basically designed for complexity, to hide the complexity of connecting multiple services together. But when it comes to REST emphasizes on readability. So anyone can basically just read the URLs of a REST API and understand what they're doing there. But when it comes to Jrpc, that's not the case. As well, on top of all of that, the last point that we want to discuss is just the difference between Jrpc and REST. So Jrpc basically it's performance driven. So as long as the client and the server and the service have the same proto file, they are basically able to communicate with each other. So the last point we want to discuss is performance. So performance in Jrpc is key. So basically, as long as the client and the service have access to the same proto file, they are able to communicate. If one of them does not have access to that proto file, there will be no way for them to communicate together. On the other hand, in REST, anyone can just pick up the APIs and they will be able to communicate. The difference is the performance gains that we get from Jrpc is really, really high. So the communication is way faster, it's more robust, it's less error prone, but again, it's not as easy to integrate with. But when it comes to REST, it's basically, we have a very big wide audience that you can utilize it. So basically anyone who can read HTTP and JSON will be able to utilize it. So that's going to be the main difference. REST is going to be way more widespread and anyone can be easily integrated with, while Jrpc is have much more control, but it's going to be way faster and much more robust. So let's take a look at the structure and the difference between Jrpc and REST. So as we can see from these two diagrams that in order for Jrpc to communicate, as we can see, both of them needs to have a proto files, and these proto files will define all of the applications and all of the methods and all of the models that needs to be sent, and all of the communication between the client and the service has to happen over HTTP2, which is binary based, using the protobuf. While when it comes to REST, basically those client and the service can be completely independent from each other, anonymous basically. All they need to do is just send a JSON or XML file over HTTP, which is text-based, and then the API will send them back in the same format, so it's easy for them to read it without having any prior knowledge of how the API works or the service works. So what's going to be the app structure for today? We're going to create a service as well as a client. We're going to be defining proto files for the client as well as for the service. And then we're going to be creating a communication between the service and the client. We're going to be first doing unary calls, and then we're going to be doing the streaming calls as well. So what do we need to get started? All we need is the .NET SDK 3.1 or higher, and also 3.0 or higher, and we need also Visual Studio Code. You can find links for them in the description down below. Now let's start coding. First, let's open our terminal. And the first thing we're gonna do is we need to verify that the .NET SDK has been installed successfully. So in order for us to do that, we're gonna type .NET -- version, and we should see a number. The current version that I have is 5.0.103, which is the latest version. If you have any version above 3.0, you should be fine to use Jrpc. If you see any error, you need to re-download the .NET SDK and install it again. So once we have done that, now let's start by creating our application. We're going to be utilizing the .NET new keyword and we'll build it from there. So .NET new Jrpc. We're going to give it a name of Jrpc service. This should take a few seconds. Perfect. Something that we might need to do depending on your own configuration is just verifying the HTTPS SSL on our local environment. So in order for us to do that, we're gonna utilize also the .NET dev cert commands. So .NET dev-certs HTTPS and --trust. You need to input your admin password. Again. Perfect. So the next step right now is let us open Visual Studio Code and take it from there. As we can see, we have our Jrpc service. Inside the service, we have the startup, which is basically similar to the ASP.NET Core application. We have a program which has already been defined for us, similar to also the ASP.NET Core. As well, we have a folder which is called Protos. Inside the Protos folder contain the Proto File that we need, as well as if we go to services, we have the service which utilize the Proto Files. Perfect. So, first, let us discuss the structure of a Proto File before we delve into any development. So, the first line in the Proto File is, it says syntax equal Proto3. What does that mean? So this means, let's add comments here as well. So this means, similar, for example, when we have an XML file and we define the schema of that XML file, in a Proto File, the first line usually define the version of the schema. In our case right now, we're utilizing Proto3. So define schema of Proto File. Perfect. So the second line here, it says options C# underscore namespace and Jrpc service. As you can tell from this, it utilizes the same namespace that our application has in order for it to directly link to our C# application, which is great. Thirdly, which is going to be the package. So let us add, before we explain that, let us more comment. So basically it's define the namespace based on our application. Package mean once we want to build it and it creates the DLL files for us, because it's an auto-generated code, the package for these DLL files, they're going to be under the greet package. So now we can see we have something called service and we have a greeter. We can think of a service as like a class, and we can think of these functions here or methods here as our actions. So a service is basically, service is a class. Let's say we can think of a service as a class. So basically a service can have multiple actions similar to a class. So as right now here, this service only have one method, which is say hello, but we can have as many methods as we want. So the next, we can see we have something called message and message. What does this message mean? Message basically is like represent a model in C#. So we can define the properties inside of them, and we can define as many properties as we want. So let's remove this. A message is like a model. And you can see here that also we have one. So what does that one mean? One mean it defines the order of our variables. So let's say we have a string name, string last name, or string email, for example, equal to string, for example, phone equal 3. So the numbering system here is just to tell the application on which order it needs to generate those fields for us. So first name, email, and phone. Usually this is used in order when it's automatically set up within the constructor, and it's much more easier for different clients to have the same ordering of those parameters inside that model or inside that message in order to be consistent across. So numbering every item of every property here is really, really important. And at the end here we have another message which is also like a model, which also has one field into it. Let us discuss more about the say hello method that we have here. So as we can see, first it has the keyword RPC. The keyword RPC here, basically it tells the code or the code generator that this is an RPC function. Then we have the name of the method, and then we have the parameters. So what is this method's gonna take? The parameter, we can say it's gonna take an object that contain a name, and then what is it gonna return? It's gonna return, for example, hello reply, which is also a model which contain a message. So this method here, if we're gonna create it in C#, it's gonna be something similar to this: private hello reply, say hello, and hello request. So this method here, when it's the code auto generates, it's gonna be converted into something like this: the hello reply, which is gonna be what are we gonna return, the say hello, which is the method's name, and the hello request, which is gonna be the model. Perfect. Okay, now let's continue to the service and let's discuss how it works. So under the services folder, we have something called the greeter service, and inside our greeter service we can see that it inherits from something called the greeter. And if you remember, inside the greet folder we can tell that we have something called the service here, which is basically the class, and we say it has name's greeter, and if we look, it inherits from greeter. Perfect. And then from that greeter service, it takes the base class, and then underneath we can see that we have the method, which is here. It says say hello. It has been overridden, and we have implemented our own logic inside of it. So as we can tell, we are returning a hello reply similar to the other one, and we're taking hello request. And as well, we have something called the context, which is used by the gRPC to know the context of where do we stand right now within the application. We're going to delve into these more details when we build our own proto files. But you might tell me, okay, we have this right now, but how does C# knows about the greet.proto? How does it knows that this is the method, and how did it know that there is a class name, or sorry, there's a service named greeter, and there's a method named say hello world, and it's gonna take hello request. So first, let's open our terminal and let's build our application. So cd and just type .net build. This should take a few seconds. Perfect. Now let's go to the object folder, and under debug we can tell that we have a folder name protos and inside the .NET 5 folder. And if we open that proto, we can see that we have a class called the Grpc, and if we open it, this is an auto-generated class for us. So once we do our build, this class is automatically generated for us. So if we go all the way down, we can see that a class has been created. Let's look for it. It's called the greet. Yeah. So basically, we have a partial class which is called greet reflection, which the reflection word is gonna be removed, which is gonna be the class gonna be called the greet, and we can tell, if we read it, we can tell it's being read from the greet.proto files, and this is converted from proto into C# class, and every message here, for example, is also being reflected as a model. So the messages section here, we say hello message is defined as a class, which is what we need, and inside of it, it has basically the methods that we need, or the variables that we need, as well as, let's go check the other one, hello message, and I think the other one was called hello reply. Let's check hello reply. As we can see, also hello reply has been automatically generated for us and is being utilized. So hello reply is also within its own class. So this code auto generation is allow us basically to have less error prone. It allows C# to have full control of the source code that's being generated in order to make it as optimized as possible. Let us try to run this application and see what we get. So within our terminal, let's type .net run. Okay, one more thing before I forget, because we are currently on Mac OS, and Mac OS does not really support HTTP2 over TLS. What we need to do is we need to have a small workaround within our program.cs in order for us to avoid having HTTP over TLS. This feature is coming later this year to macOS, but currently it's not really supported. So we are not able to build this application. So inside our program.cs, all we need to do is within the web builder, we need to add web builder.configure Castrol options, and it's gonna be options dot listen to localhost. We'll define the 5000 port, and we're gonna be utilizing the protocols. So HTTP protocols, .http2, and that should do it. Let's save this and let's try to run our application again. So let's try it again. And we can see the application is now running on port 5000. So let's open this in a browser and see what do we get. So I have here my browser open, and we're gonna go to HTTP localhost on port 5000. And as we can see, we are not able to get any response because basically our Jrpc server does not really have a web interface with it, and it does not really allow us to connect directly through the web. So as we said before, Jrpc relies on Proto in order for us to be able to communicate with it, and currently our web browser does not have any idea what a Proto is and how to communicate with our Jrpc service, because it doesn't really know how to communicate with it, doesn't really know how Proto works, doesn't really know what does it need to communicate. So basically the request is gonna fail. And if we look at the logs, we can see that the Rpc does not even complied with that request. So how do we communicate with it? We need to create a sample application for us to communicate with our service. This is gonna happen, we're gonna create this after we create our custom Proto File, and then we're gonna create a console application which utilizes that Proto File in order for it to communicate with the service. Now let's create our custom Proto File called customers.proto. So inside the Proto File, we're gonna create a new file. So inside our Protos folder, we're gonna create a new file called customers.proto. Great. So the first thing, as we mentioned before, we need to define the schema, which is going to be the syntax. So in order for us to do that, syntax equal, we're going to be utilizing the latest one, which is Proto 3. The next step is we need to define our namespace. So it's going to be option C# namespace equal. So let's make sure it's the same. So we can take it from here, and the namespace is Jrpc service. So copy paste that. Great. The next step is the package. So package, it will be customers. After that, we want to start defining our service. So as we said before, a service is like a class. So service, we're gonna call this service customer. And basically, for now, we're only gonna have one function, one method, but we're gonna be adding to this later. So the first one is gonna be Rpc. So we're gonna tell that it's an Rpc method. The method name is gonna be get customer info. And then we need to define a model, and we need to define basically an input model and output model. So the first model, we're gonna be defining basically a message. It's gonna be customer find model, and the other message is gonna be customer data model, which is fine. Now, how do we define these models? Basically, our messages is gonna be message, and it's gonna have the same name, and basically it's gonna be type int32, and it's gonna take a user ID equal to 1. So as you can see here, usually when defining a class, we can define the type of the attribute that we have. So it can be either an int, a bool, a float, a double, and a string. So when it comes to a Proto File, these are the types. So let me just add them here. It can be int32, it could be a bool, it could be a string, a float, and a double. So int32, it's equal to an int, boolean, string, and the rest should be the same. But for example, we cannot define here, for example, an array. We cannot define an array, or we cannot define a list. There's different ways, more advanced way in order for us to do that. We'll pick it up in a future video, but for now, let's just utilize what we have, which is these basic types. And we defined number 1, which is going to be, because it's the first one that we have here. The second message we're going to do is the customer data model. So message customer data model, and this one's going to basically contain only first name, last name. So in order for us to do that, we're going to be string first name equal 1, and string last name equal, if I can type, equal to. Perfect. Let's save this, and now let's go back to the object folder and check this. So currently we don't have anything related to our customers model. So there's a few steps that we need to take after we create the customers Proto File in order for it to automatically be generated. So the first thing is inside our grcp service.cs proj, we need to add that Proto File here. So how can we do that? We can just copy this, paste it, and instead of greet.proto, it's called customers.proto. And because this is the server basically which is gonna be utilizing generating the application, and basically this is gonna be where all of the clients gonna be communicating with, we need to define that this is gonna be a server, a service type. Perfect. And now let's click on save. And now as soon as we click on save, you can see here that it has automatically built the protos for us, and it automatically generated the customers class for us. So let's just do a .NET build. Great. And now if we go to the customers.cs, we can see that our class has been automatically created for us. Our method should be here. So our method name was getCustomerInfo, and if we look for it here, we can see our method getCustomerInfo already exists here. It was in the customers Jrpc one. So it has already been here, and we can see that it takes the customer find model and it returns the customer's data model. So all of these has been automatically created for us, and it has already identified the type for it, which is a unary method type. What does the unary mean? It means like when we do a request, it's going to return for us a single response. It's not going to return for us like multiple response. It's not going to return for us a stream of responses. Unary means it's going to be a single response we're going to be getting back. We're going to create another method after this, which is going to be a stream, and we can see how this is going to change here. So for now, since we already have this, let's now create our customer service and build on top of that. So inside our services model, we're going to create a new C# class, and we're going to call that service customer service. And the first thing we're going to do is we're going to inherit from the customer class that has been automatically generated for us, and we're going to be using the customer base. So basically these here, this customer class that we have here is the one that has been automatically generated for us here inside our protos folder. And if you want to make sure again, if you can take a look inside, and we can see that the service name is customer, and the .basic class means it's just like the pattern that we need to follow, because it's part of the auto-generated code. Once we do that, the first thing is we can add a logger. So private read only ilogger, and it's gonna be customer service, and we're gonna call it logger. Perfect. The next one is gonna create the constructor, and it's gonna take, and let's copy this. And it's gonna be underscore logger equal logger. Now let's fix these references. Okay, great. The next step after that, we're gonna be overriding our get customer information. So how do we know, how are we gonna basically, how do we know what's the method that we're gonna be overriding? A very easy way for us to do that is just typing public override, and then we click on control space or command space. You can see that we have the method get customer info automatically populated for us, and if we select it and hit enter, we can see that all of the methods information has been showed for us. So it created for us the output, the input, as well as anything else which is required, which is in this case the context. So we're going to be deleting this, we don't really need it right now. And basically, if we take a look at the output, it should return a customer data model. So we're going to create that. So we're going to call var model equal new customer data model. And basically this function right here, it's gonna take an integer, as we said before. Let's take a look back here. So basically what it's gonna do is gonna take a user ID, and it's gonna return for us the first name and last name. So basically it's trying to mimic a call to a database, trying to match an ID with the user and get the user information back. So for this reason, we're not gonna be connecting to a database right now. We're gonna use static data in order for us to get the information, so we can try and mimic a database behavior. So in order for us to do that, it's gonna be very simple. What we can do is we can do just if else statement. So if request dot user ID equal 1 will return model dot first name, it's gonna be my name, Mohamad, and model dot last name, it's gonna be my last name, Lawand. And let's say if else, for example, if request dot user ID equal 2, we're gonna be returning model dot first name, let's use Homer, and model dot last name, it's gonna be Simpsons. Okay, let's copy this so we can save a bit of time. Let's do another 2 options, and that's it. Okay, so the last one is gonna be so the third one here, let's say 3, it's gonna be, for example, Bruce Wayne, and in case it doesn't match with anything, let's return, for example, we can return Mickey Mouse. Okay, great. So once we have this, the next step for us is just to return the result, which is very easy. We're just gonna do return task dot from result, and we're gonna return the result. What did we do? Sorry, it's gonna return a model, not result. So why did we do a task dot from result? Because if we look at the signature, it requires to be a task, because in case we are doing a call to a database, this needs to be an async function, and for it to be an async function, we need to return a task. So this is why we're returning a task here dot from result. Let's build this, make sure everything is working. Great. So after we create our service, the next step is we need to tell ASP.NET Core that there's gonna be a new proto files that we might connect with. So first proto files that we have is gonna be greet.proto. The next proto files is customers.proto. Currently, our .NET Core will not know about it because it's not injected within our startup class. So the middleware that's going to be responsible for initializing the proto files and utilizing all of the auto-generated code is not really there right now. It only currently know about the greeter service that we have. So how do we tell it about the customer service? It's also very easy. We need to go to the startup class, and if we go all the way down here underneath the endpoints, we can see that we need to map to the new Jrpc service. So we're gonna add endpoints dot map Jrpc service, and we're just gonna give it the customer service. And let's fix the references. Customer okay, I mistyped customer service here. So sir this, okay, so I apologize for the typo. Okay, save. Let's rename that file. Okay, perfect. And here all we need to do is just add the reference. Great. So now we have informed our .NET Core startup class that we have a new service that a client might connect to. So So now let's create our client application and see if we are able to communicate with this service. So in order for us to do that, we're going to be also utilizing our terminal. So we're going to create a new console application, .NET new console dash, let's put name, I'm going to call it Jrpc client app. Just to take a few seconds, sorry. Now it has been created. Let's navigate to it. The next step is we need to add the packages. So .NET. So the packages we're gonna be adding are the Protobuf ones, the Jrpc Tools, and the Jrpc client, in order for this console application to know how to communicate with the service. And basically, in order for us to do that, it needs those packages. So the first one is going to be Jrpc client. So .NET add package jrpc.net.client. Just to take a few seconds. Great. The second one is going to be .NET add package google.protobuf. So Protobuf, just like an FYI, was created by Google, and then it has been, I think it was back in 2015, and after that it has been standardized and has been open source so everyone can use it. Okay, great. Now the last one is going to be the Jrpc Tools. So .NET add package, it's going to be jrpc.tools. Perfect. Now let's verify these has been added to our application by going to our Jrpc client app CS Proj, and we can see that we have the 3 of them here. Great. So the next step is we need to add the Proto file inside our application. As we said, in order for a client and a service to be able to communicate with each other, both of them needs to have the same copy of that Proto file. So how do we do that? Inside our client app, we create a new folder. We name that folder Protos, and it's going to be as simply as copying these 2 Proto files and pasting them here. And after we copy paste them, the next step for us to do is we need to tell the application that we have 2 Proto files installed. So how do we do that? We open our Jrpc client app.csproj, and inside of that, what we need to do is we need to add 2 item groups. So let's put item group, and the first one is gonna be we're gonna have a protobuf. So protobuf, and this is gonna be, we're gonna say it's gonna be including from Protos, the Protos folder, and the first one is gonna be customers.proto. And we're gonna be defining the Jrpc service as a client. As you remember, in the server one, we have put this one as server. Let's just double check that. So if we go to the Jrpc service.csproj, we can see that here it has the server attribute because it's on the server client. Within our console applications, it's a client. We need to add it's a client service. So let's copy this and paste it, and we'll add the other one, which is going to be greet.proto. Great. So once we have done that, the next step is we need to do minor updates to our customers and greet.proto. So the thing here is, let's copy the namespace. We need to update the namespace. So instead of having C# name, Jrpc service, it's gonna be the Jrpc client app, similarly in the greet. Perfect. Once we have done that, The next step is for us just to build the application and see if everything is running as it should be. So .NET build. Perfect, build succeeded, would not break anything. .NET run. It will not do anything, but let us run it and see. It gave us the hello world that we expect. Perfect, so we see here it's running as it should be. Now let us start by connecting to our service, and let's add the code that's going to be connected to our service and execute a command against it. So let's keep hello, let's call it hello Jrpc from Mohamad, for example. Nice. Okay, the first thing that we're going to do is we're going to be creating a channel. A channel is like a dedicated call, you can think of it in that way. So a channel is like a tunnel in a certain aspect between the client as well as the server. So that tunnel is gonna be defined by the URL of the server, and then we can utilize this tunnel in order for us to request. So how do we do that? Very simple. We call it var, create a variable, we call it channel equal Jrpc channel dot for address, and then we'll put the URL here. So if you remember, within our service side we have added the port 5000, localhost 5000. So that's what are we gonna use. So we'll put here HTTP localhost and the port 5000. In the real world scenario, this needs to be configured from the app settings, and it needs to be injected here. It should not be hard coded. So this is the channel that we have created. Let's add channel to communicate with the service. So once we have created a channel, the next step for us is we need to initiate a client. A client means once we have created the tunnel between our client and the server, we need to create like a client in order for us to identify, okay, with which service or gRPC service we wanna communicate with. Currently we have two. We have one for customers and we have one for Greet. How does our console application is gonna know with which of these services we need to connect with? By creating a client. So how do we do that? Very simply, we create a variable var customer client equal new customer dot customer client, and we're gonna pass it the channel because it's gonna be based on that channel that we have initiated earlier. Once we have that, now we can simply call the functions that we have there. So one of the functions, actually the one function that we have within our customer service is get customer info. So we're going to be utilizing that. So how do we call that? So first we define a variable result equal await customer client dot. As you can see, it has automatically been populated for us because the code has been automatically generated for us when we build the application, because the Proto Files has been added to the service. Very easy, very straightforward, and very intuitive. And all we need to do right now is to pass the parameters. So this function here takes a customer find model. So that's what we're gonna be adding. So new customer find model, and we're gonna be defining the user ID equal to 1. And let's add this here. Okay, and now we're just gonna console write line the results. So console dot write line. Let's do string concatenation, and we're gonna put first name. It's gonna be a result dot first name, and okay, last name. It's gonna be result dot last name. Okay, great. So how do we run this? So let's create two terminals. So this is our first terminal. If we click here on the plus sign, it will create a new terminal for us. So let's log in to this one. It says I'm having an error here somewhere. Oh, sorry, I didn't put the semicolon at the end. So let's navigate here to the service, Jrpc service, and let's put .NET run. And once we run it, we can see now it's listening to port 5000. Great. Now let's navigate back to our first one, and let's .NET run again. Okay, we have an error. What's the error? The channel name Jrpc channel. Oh, I forgot the L here. Apologize. So let's save it again and let's run it. Okay. The Jrpc channel does not exist in the current context. Oh, we didn't add the using statement. So how do we do that? It's very simple. So all we need to do is go up, and we're gonna be adding using Jrpc. What was it? Jrpc .NET .client using Jrpc .core. Oh, as well, we are awaiting something inside this, and this needs to be async. So we need to change this from void to async task. Save. Task is going to be using system.threading, using system.threading.tasks. I think this should fix it. Perfect. So now we are able to communicate with our service. We got hello from Jrpc, hello Jrpc from Mohamad, and then we can see that we got first name and last name Mohamad. Now let's change the user ID from 1 to 2. I think we should get here Homer, I think. Perfect, we got Homer Simpson, and let's put 3. I think we'll get now Bruce Wayne. Perfect, and the last one, let's put 8, because now we should get, I think, Mickey. Great. So now we have made sure that our application is running as it should be between the client and the service, and we have tried out a unary call. The next step for us is to add some stream capabilities. So this is a basic Jrpc call, and unary calls are basically very simple. So we send an object and we get a result, a single result. But also Grpc supports something called streaming. Streaming means like we can send different results simultaneously at the same time. So we can send, for example, 10-15 results, one after another, so as soon as they are available. So it's not like we are sending a list. If we are sending a list, we can do it with a unary call. We can prepare that list and send it one time to the user. But a stream is like, for example, let's say we are reading from an API. The service is reading from some sort of API, and we don't really want until all of that objects being read from the API to send it back to the client. So a stream means as soon as we get any results back from that API, it sends it one by one. So as soon as they are available, it sends it. It does not like collect. It does not package it all in a single object and send it back. It sends it one by one to the client. So let us try this, and let us build a stream method. So the first thing we need to do is we need to first let us stop the server. And let's go back to our Jrpc service. And inside the customers.proto file, we need to add a new RPC function. And it's gonna be RPC. We're gonna call it get all customers. And usually, if we're doing get all or getting all of the information, we're not really sending a parameter. So if we're saying get me all of the customers that you have, we're not really sending any conditions. So we don't really need to send a parameter. But within Jrpc, we cannot have a method that does not have any parameters. So in order for us to work around that, what we need to do is we need to create an empty message. I'll show you right now how we can do that. So the message we're going to be creating is going to be all customer model message, and it's going to return a stream of customer data model. Okay, so let us first discuss what does the word stream here and why it's only returning one customer data model. So right now, as we said before, we have the RPC get all customer client. This is our method. It's gonna take, it shouldn't take any parameters, but Jrpc does not support it does not support methods without any parameters. So for that, we need to declare an object, which is a message here with empty parameters, and then we need to return the customer's data model. But you can say, okay, we're only returning one customer data model, we're not returning a list of them. But we have the word stream here. The word stream here means that we're going to be returning the customer data model one by one. So that means that as soon as one of them is available, we're going to be sending it back. So let's display this process in a more illustrative way. So let's go back to our web browser and let's go to draw.io. Okay, that's fine. Okay, so first let's say this is our client and this is our service, and okay, so this is going to be a Jrpc service. So let's say Jrpc, and that's the service. Okay, so let's do the request. So let's take this, put this here, and let's copy this and put it here. Okay, so the first thing, for example, what are we gonna do is the client's gonna send a request to the service. It's gonna tell it, okay, get me all, I want all the customers. The Jrpc service is gonna receive this call, and if we go back to our source code, we see it's gonna return a stream. So how does the Jrpc send this back the information to the client? So in a normal call, let's copy this and we illustrate how it works within, for example, JSON or a normal REST API. Okay, let's copy this, all of this, copy, paste. So in a normal REST service, here, the service or the REST service, basically, it's gonna combine all of the results and send it in one request. So all of the work that's gonna be happening here, let's give it a blue, and then after all of this work has been done, we're gonna have only a single request. Let's put this here, and let's put this back. And what this single request gonna have all of the results. So It's very simple, and this is the method basically we're used to. We send a request to the service, it's gonna do all of the heavy lifting, and then it's gonna send us one result, or one response with all of the results. This is not what's gonna happen here within the Jrpc service. So what's gonna happen within the Jrpc service, specifically that we have added a stream. So let's copy this, let's create a new one, it's fine. And here it's gonna start streaming the results. What does that mean? So let's give it a nice color. It means that, for example, let's say we have 15 users. So as soon as one of the first users are available, it's gonna be start to sending it back. So let's say we have 15 as we said, so we're gonna be receiving 15 responses. 2, 3, etc. and etc. Let's put one more. Okay, so the service here, after this is the request has been received, as soon as the service has gotten the first result, it's gonna send it back to the client. As soon as the service got the second one, it's gonna be sending it back. So we're not really combining all of the results into a single response. No, we're just sending it as it's available. This is a way faster way for us to start processing. So let's say this one can take up to few seconds. No, let's say it can take up to 150 milliseconds in order for the REST API to get all of the information, combine it, create a JSON object, then serialize that JSON object and sending it back to the client. While here within the Jrpc service, as soon as we get the result, the service is gonna, okay, I already have it ready. It's gonna convert it to a byte array. No need for serialization because it's gonna be using the autobuff and protobuf, sorry. And once we have that byte arrays are the byte values are ready, it's going to be sending it one by one, and the client here is going to be receiving it one by one. So this is what we're going to be implementing right now, how we can implement this type of functionalities. So now let's go back to our source code. So first of all, we didn't define all customers model. Let's define it right now, and then we can jump into defining that the service for this. So what are we gonna have within the all customer model? It's gonna be very easy. Basically, as we said, it's not gonna take any parameters, so it needs to be empty. So in order for us to do that, we're just gonna create a message. We're gonna call it all customer model. And then it doesn't have any body. So just to recap, every method within Jrpc, it needs to have an input parameter, even if it doesn't need to. So in this case, we have created one with an input parameter, but it does not return anything. Okay, now let us build it. So because once we build it, the files will automatically, the auto-generated call will work. So .NET build. And now it's building, and now we can verify that it has been added. Let's copy this, and let's go to the object, debug, protos, customers, grcp, and we can see that our method has automatically generated for us in a customer grcp. Great. So now that we have this added, now let's update our services, customer service, and now let's add the method for us. So again, as we did before, in order for us to know the function that we're going to overwrite, so public override, and then with the control space, and we can see get all customers. We click on this, and we can see that so it will be more visible. We can see that this is the request which is going to be receiving, which basically is going to be empty. And we have something very interesting here. We have something called the Iserver stream writer, and it's going to return a stream of customer data model with that response stream, and the context we're going to be utilizing in maybe future videos, not right now. But what I mean right now is what's really interesting here is the Iserver stream writer. So the Iserver stream writer, basically, this is what's going to allow us to have this response. It's going to start 1, 2, 3. It's going to be sending back results as soon as they are available. So how do we implement this? It's going to be also very easy. We're going to mimic a database structure. So we're going to have a list of customer models that we're going to be returning. So var all customers equal new list of customer data model. And then I think here it needs to have, yes, fixing the references. And so let's basically create, okay, so it's gonna be var c1 equal new customer data model, c1 dot first name equal Bruce, and c1 dot last name equal Wayne. And then we're gonna put all customers dot add c1. Okay, now let's copy paste this. Okay, c2, and instead of Bruce Wayne we're gonna put the Homer Simpson. Let's put c3, and let's put Tony Stark. And the last one c4, and we're gonna call this guy let's call it Mickey Mouse. So now once we have our list, which is currently have 4, what we're gonna do is we're gonna start returning these to the user. So how do we do that? Very, very simple. For each var item in all customers. So we're just looping through those lists, and basically await response stream dot write async and item. So what is happening here? Okay, so this is await, so we need to make this async. Okay, so here basically we are mimicking a database functionality. We're just adding stuff to a list. Basically we're trying as if we are doing a select all on a database. This is the interesting part. So once we got our results back, we are utilizing the response stream, which is here, in order to send every item one at a time. That's very, very interesting, because as soon as we have that item ready for us, we are sending it back. We are not combining it all in a big response object. So let's save this, and now let's update our client in order for us to utilize it. So how do we update the client? So the first thing is we need to update the proto files. It needs to be exactly the same. So what we can do is we can just copy this and go to the client proto file and add it here. And second, we need to update the model that we have created. Perfect. Now we have updated the proto file. So after that, we're just gonna do .NET. Let's go navigate to the other one, to the other project, to the client app, and we're gonna do .NET build. And this will automatically generate for us the code for all customers within the client. So let's go, to object, debug, Protos Jrpc. And if we look for for the method, and we can find it has been automatically generated for us within the client app. And after that, we're just gonna be implementing this inside our customer and our program, So let's leave this and let's add the functionality underneath here. So basically we have already defined the channel, we have already defined the client. All we need to do is utilize this client with a new method. So var, we're gonna call it all customers, all customers equal customer client dot, as you can see, all customers has been automatically created for us. Perfect. And then we're gonna send it an object, which is gonna be an empty object because we need to send an object for every RPC request. So it's gonna be a new all customers model, and it's gonna be empty, it doesn't contain anything. And in order for us to utilize the streaming functionality within our client, we need to utilize a for each with an await. So await for each var customer in all customers dot response stream dot read all async. And now we're gonna just output it to the screen. So console dot write line. Also we're gonna do string concatenation. It's gonna be customer dot first name, and it's gonna be customer dot last name. Before we run it, let's discuss this await for each. So a normal for each without this, for every time we're trying to read this, what's gonna happen? The thread is gonna be blocked until all of the process has been all of the task has been processed, which is not what we want. Basically, the main idea behind this methodology is that we want to display the results as they come. We don't want to wait until everything is completed. So when we have await for each, it means that every response or every task that's run is going to be running on different threads simultaneously. So as soon as one is available, it's going to be displayed. We're not gonna do any like blocking on the threads in order for us to for one task to complete so the next one to work. We're just gonna make them run simultaneously. So let's save this, and now let's run the server. Let's go to the server terminal that we have created earlier and type .net run. We can see the server is running on port 5000, which is great. Now let's navigate back to the other terminal and type .net run as well. And we can see hello Jrpc from Mohamad, first name, last name, first name, last name, first name, last name. So we can see that Bruce Wayne, Homer, Tony, and Mickey has already come through. But this is really fast right now, and we cannot really see the benefit of it. So what we're gonna do is we're gonna add like a delay just to mimic a network call within our server, just to see how this wait's gonna work. So in order for us to do that, let's navigate back to our client server, customer service. And here, what we can do is we can add task.delay, and what we can do is we can put 1000 milliseconds, which is 1 second. And let's await this. And let's stop the server and run it again. So now with every time we're trying to loop, we're just gonna wait 1 second. And this is gonna illustrate a bit of network traffic, if you want, or network calls. So .net run, and now we can see the first one has been happened, and then we can see we are just waiting and we're streaming the result as they are coming to us. And this is really, really, really powerful, because imagine if we are in like an IoT scenario where we have very limited network bandwidth, and we want to send some updates to those IoTs. We can utilize this in order for us to send the responses, or we send the command one by one to that small IoT device in order for it to run, instead of waiting for a big chunk of commands to go at one time. So basically, as a summary, let's do a quick recap of what we have completed today. So the first thing we did is we have created a gRPC service, which is going to be the service which is going to be responsible to providing data. We have created our own Proto file. It's called customers.proto. Inside this proto file, we have defined the packet, we have defined the syntax, the namespace, we have defined the service, which is basically, as we said before, refers to a class. We have defined all of these messages, which is basically the models that we're going to be utilizing. And then we have defined two methods inside the service. One of them is a unary, which is going to be single response, and one of them is stream. So it can return to us multiple responses while on the same requests. And after that, what we did is we have created our customer service, and we have implemented these two services, the customer info as well as get all customers. And we saw here how we can send the stream back, a stream back to the client. And then after that, we created a client application, which also we went through the process of how we can let it know about our proto files. So what we copied the proto files from the service project here, and then we have added it to our CS proj, and then we have created our commands in order for it to communicate with that service. So basically, first we create like a channel, which is going to be the tunnel between the service and the application, and then we have initialized a client, and then after that, basically we just implemented those two services. So it's pretty straightforward. It can get really complicated if we based on the implementation, but the idea behind it is it remove a lot of the complexity. So if we think about this in a JWT or a REST API implementation, we need to have implemented the serialization, the deserialization. We needed to do the processing of that JSON file, for example, on the client and on the server. So this here have removed a lot of the complexities that we have, but on the other hand, it reduced some limitation that the clients needs to know about the service profiles, and it needs to have that same profile available for both. As always, the source code will be available in the description down below. You can get it from GitHub. And thank you a lot for watching. Please like and share if you like this video. Have a good day.